Okay. So welcome to week 5. Welcome to week 5, and we are so proud of everyone who has stuck through every class in the Intro to Data Analytics course. You should be very proud of yourselves. And obviously, this is our last course or class in the course, I should say. So for anyone that just joined us, make sure that you do put your name into the chat so that we have your name for attendance on Zoom. And of course, in the classroom, in the library, we'll get your attendance the typical way. We have a lot on the plate for tonight, but we're going to mix it up a little bit as far as the order. And I believe Yulia is going to be talking about some of the courses that are coming up. And you want to take notes about days and times and such so that you will be able to factor those into your schedule. I just want to go on record and say I'm very proud of everyone, and I want to encourage you to keep staying motivated, stay the course, and just think about the learning opportunities, which are so important. All right, so Yulia, are you ready to take it away?
Yes, absolutely.
Oh, wonderful.
Sharing my screen right now.
Okay.
So first of all,
There we go.
Congratulations, because you're receiving these certificates. Right now, I have certificates printed for those who attended all the classes and did homework.
Yay.
So as soon as you go and finish some class materials, we will be giving you certificates printed, or if you want to have it as a digital copy, you can download it and publish it on your LinkedIn and such. Okay, so you have to contact me. I am here 5 days a week. If you want to grab it printed, it will be waiting for you in Tech Hub. If you want to have it in digital copy, I am going to send it to you. Some conditions has to be met, right? So Dr. Cynthia has to approve you passed some homework. At least we don't require 100% of the homework to be completed, but we want to see at least like 50+% of homework completed.
That's right. That's right. Honest effort is what we're looking for. And, you're not going to be perfect the first go around, but the fact that you gave it your best efforts, that's really what's important. And that means that you grew from where you started. So
we are in the 5th class today, and just your presence, no homework is expected, your presence, and dive deep into what's coming, how we're wrapping the previous course, the first course, or like zero ground up course for data analytics with the Python. Right, so tonight is the last class in this intro to data analytics, and we're starting with the first course with bootcamp with Excel, back to roots.
Yep.
Okay, so we'll switch back and forth between Excel and Python, and between Excel and other programming languages, whatever is applicable. The best thing you will learn actually what to use, when to use, what's the appropriate, and what is scenario. But I'm just saying, first of all, I'm excited to say that bootcamp will continue on Thursdays, like it was, same time, same scenario. Dr. Cynthia will continue it in a hybrid mode. You can connect on Zoom, or you can connect in person. And we have all these office hours available for you. Look at this. Office hours on Monday, office hours on Tuesday, Wednesday, Thursday, Friday, and data analytics specific office hours on Saturdays. Please don't miss it. Okay, the more you practice, the more you see each other's code, the better you are with technology, with data analytics. For those of you who are starting data analytics bootcamp, yes, we do start with Excel, but we're starting with Excel intermediate up. So that's why we do believe you need to catch up a little bit, refresh your knowledge with Excel. That's why we're offering free Excel catch-up class, deep dives classes. And we will bridge between the Tech Foundation 2 class basic Excel, and we will bridge between Tech Foundation 3 Excel intermediate formulas we already learned. It's really helpful formulas, I shall say, because, for example, I noticed Shalan didn't know about VLOOKUP function, which is extremely helpful. Okay.
Yes.
So we will expect you to know some formulas here, and we will do more advanced. So you need to build your foundations with Excel. So that's why everything is here to equip you with going forward. One more thing I will mention
What
here.
time is the Excel class?
Mondays on 10 to 1, free Excel classes.
Oh, they're 10 to 1.
We want Excel classes. We actually want to repeat basic Excel. We want to do intermediate Excel. And we'll repeat the condition free.
Will you take them or?
No, but we can run it again and again. And Bryant is here. Roman is here. So we can actually, how do you call it? Make it up? Mock up it? Not mock up.
Retake it.
Yeah, you can retake it on demand. So we need at least 3 students to do it as a class. Otherwise, it's office hours. Okay? Make sense? So that for the class, it's one-to-many broadcasting model. We're good. If you want to practice Excel, any office hours are well.
I was doing Excel for about 10 years,
You're good.
and I don't know what part of Excel has happened in the last 10 years, because that's what I don't know.
So did you take our Tech Foundation free class with Excel?
Yeah.
All these 5 functions? Was it comfortable for you?
Yeah.
All 5 functions you were comfortable with,
Now
including pivot tables, PMT functions, what it was, data tables.
I don't know the names. This is the problem. I know how to do it.
So it's
but I
worth to
don't know
refresh
the
it.
names.
That's what I'm saying. It's worth to refresh it. And more important, it is to know what exactly to use and in what scenario. You have to solve these analytical tasks and like, what tool shall I use? What's the best way to approach it? It's really complicated. It's experience, it's business experience. That's what you bring to the party when you are applying to the job. You say, I have experience. I know what to use and when. I've done this project, I've done that project. I did gap analysis, I did.
And I was doing financials.
Mhm.
Good,
on
so you
Ex-
have
on
foundations for
Excel.
sure.
You know, we had pages, and then we would whatever it is, reduce the pages to 1 line, and then put those 4 pages 1 lines into the front page, which was the financials.
That's good.
So you did summary analysis then. You took the
Yes.
transactional level and you summarized them. Yeah. Yep.
I know how to summarize, but I don't know what the words are.
So welcome to learn those. Okay.
Yeah. Yeah. Absolutely. Absolutely. Wonderful.
Last thing I will mention here, just pay attention to this. We just penciled it. So it's not the final, how to say it. We need to make sure the library is, it's not the library, wait a second, it's on Zoom, Wednesdays.
That's right.
Library is not available on Wednesdays nights. That's why we thought it's a good opportunity for you to take this amazing workshop. SWOT analysis for career development, SWOT analysis of your personal strengths, your personal SWOT analysis for your career. How do you choose? What the niche is good for you? SWOT analysis is data analytics.
I just used Excel.
And what time is that on the 23rd? Rita?
We want to do it at 6 to 7:30 at the evening on Zoom.
Mhm.
To make it comfortable for everyone, this will be recorded. That's what we like about Zoom, it will be recorded. So if you don't know about your strengths, welcome, you will learn. You have a question?
No.
No, you're good? You excited? I just need to find it, confirm that everyone like is in place, but Cynthia can do it, I can do it. I hope you can do it, right? We don't need much.
That's right. As long as everyone's interested, we will run it and we'll be available for you. But we need to know that people are going to sign up and you will learn a lot. You will learn a lot. And we will be using Excel. And one of the things we'll be doing is a SWOT analysis, but we will also factor in a gap analysis and talk about what's the difference between them. But again, applying it to your personal career and your career development pathway.
Nobody will admit they have some gaps.
Oh, no gaps. No gaps here.
Where's gaps? Okay, anywho. So we will have some fun for sure.
Yep.
Say that I will stop sharing. My part is done. So you know how and where to grab your certificates. you know, you have to contact me about that, right?
Yep.
And Dr. Cynthia, this is your last class for today. Let's make it exciting and let's explain what
Absolutely.
difference. Where is my mouse? It's not the right one. Okay.
There
What
we go.
is between intro to data analytics and real data analytics bootcamp?
Ah,
What
okay.
are you doing?
So we will be doing quite a bit in the boot camp, and the boot camp will go from starting next week all the way through January. So it is intensive, but it's over a long period of time. So the first 5 classes we'll be focusing on Excel and how we use Excel to look at patterns in data, use special formulas to clean up the data, and so on and so forth. And we're actually going to be using an awesome data set. And I'm not going to share what that data set is, but once you see it, you're going to be like, wow, this is really cool. So this data set is used in the real world in industry right now by a large corporation. Once I mention it, you'll know who they are. And so having the understanding of how to work with that data, how to analyze that data is very important. So the first 5 weeks will be classes about Excel and using Excel to identify patterns that are either problematic or good about the data. One of the things to think about is when you get data from the industry, from different list areas, that data may have artifacts in it or things that need to be taken out to make that data usable. So there might be extra characters, there might be inconsistencies in the data, there might be things that need to be tidied up, we'll say, before you can actually analyze that data. And I'm going to show you some of the techniques and some of the patterns that we can identify by using formulas. Because let's face it, if you have millions of records, your eyeballs are going to get tired looking at those records. Why not develop formulas that can scan the data and tell you and flag that data as being problematic or suspect? I'm going to show you how to do that. So it's very a lot of work in Excel and getting you used to using Excel as a tool. Once we get through that, then we're going to go on to the next class. And again, the Python that you've learned thus far is very important. If you did not learn Python, let's say you didn't take the Intro to Data Analytics class, then we want to talk about how to get you caught up so that you can feel comfortable. So we would encourage you to reach out to Yulia and the team and find out how you could get caught up on the data analytics portion so far, the Python that all of you folks have been working with. We have all the lectures recorded. We have the homeworks out there. Some of the students are going to showcase their homeworks tonight, and we have wonderful teaching assistants to help you in office hours. So you really want to take advantage of that if you did not get through the data analytics, or if you got through intro to data analytics and you feel you need just a refresher, right? So that's what we're here to get you oriented to. Now, why is the boot camp important? The things that we're going to be doing in the boot camp involve different software. So far, you've learned about, well, you've learned Excel, right? You started that process. You've learned about Google Colab, but I'm going to be introducing you to other data analytics software, one being RStudio and another being Tableau. Tableau is used for visualizations. RStudio is another language. R is another language that is used very much in the industry for data analytics. And what you will find is that you will choose to use R or Python or both, and you can actually integrate them. And there's a reason why you would use one over the other. Those explanations I will talk about in class, but you really want to know both of them, R and Python. Okay. The reason for that is when you go out and get a job, they're going to have an expectation that you've at least been exposed to them. And so the goal with the boot camp is to get you exposed and comfortable. The other thing to remember is you will be building notebooks like the Jupyter notebook you did in data analytics, but you will be putting them in a GitHub account so that you have a portfolio of work and projects that you've done. That then serves as documentation for a future employer or a current employer. Maybe you want to take on a different role and you want a promotion. So you will actually have record of all of your work, all of your projects, and you can showcase it. And it's as simple as putting that on your business card and handing it to a colleague, an employer, at a job fair, what have you. right? So this is my experience, and you have it on your business card. So that's the goal. So the boot camp is important. It's a deep dive, but we do it over time. Whereas in prior versions of this boot camp, we did long hours in the class. What we're doing here is a little bit differently. We're doing, a couple hours at a time each week so that you build your skills gradually. And we find that that works for people because if you're busy working or you have family obligations, you have, a busy life, and it's just too much to sit in a classroom for too long, doing it, a couple hours each week is going to be better for you. So it allows you to learn the information in small bites rather than large bites. Okay. Now, the beauty of it is all the material will be on Open Hub, so you can go back and pull those materials down and organize them on your computer. So you'll have a reference and all the recorded videos. These are skills that normally you pay lots and lots of money for. So I'm really honored to be able to share those learning opportunities with you because I know in the industry how valuable these skills are. And again, you might choose to apply it to a specific area like finance or retail or education or what have you. We will talk about domain specific applications of those skills. And we'll also talk about the data analytics life cycle and what that means. And we'll actually be applying an industry framework. So every data project that you get put in front of you, you'll know, what do I need to do step 1, step 2, step 3, step 4. It's a very methodical process. So you'll know, you won't be scratching your head saying, where do I start? I'll show you a framework, and you'll always have a roadmap on how to approach any data analytics project. So by having that, that guides you through the process. We haven't talked about that yet because it's somewhat advanced, but you will have that roadmap and all the PDFs and documentation with it. Okay, so that being said, I know that some of you may have questions. What we're going to do tonight, I'm going to do a demonstration. Now you can follow along, but the idea is that you'll have the demonstration, you can practice it later. What we do want to do is make sure that we leave enough time for some students to share and showcase the projects that they've worked on so far. So I'm going to be asking for a couple of volunteers, and I know I have some. If you're on Zoom, you'll share it on Zoom, and basically walk through your projects and explain your approach, your thoughts, maybe areas where you got stuck or you weren't sure. And it's just a great way to deconstruct some of the work that you've done thus far. And I've seen some really awesome notebooks. So you should be super proud. Okay, super proud with your accomplishments. All right. So without further ado, I'm going to go into the PowerPoint, talk about some facts, then go into the demonstration. And again, we're going to be using that same data set that you did for homework. All right. So why don't I go ahead and share my screen and get this started. All right, here we go. Okay. All right. So this is class 5. Yay. For you guys that made it through, you should be so proud of yourselves. How cool is that? So what are our topics for today? Well, you know what a Jupyter Notebook is, right? We've been doing those in Google Colab. But tonight I'm going to show you exploratory data analysis. So last week you focused on some of the descriptive analytics and the basics, and we started to talk about charts and things of that nature, but I'm going to take a deeper dive. So you'll see some things that might be similar to what we did last time. So hopefully that jogs your memory, but then I'm going to take you a little step further. So naturally we're going to develop a program in Python. I am going to be using the diabetes data set that we did, the Pima Indians data set. And I'm also going to show you some basic cleaning techniques and wrangling of data. Wrangling of data is taking the data and putting it in a format that works for your inquiry, whatever your questions are about the data, right? So that's something I'm going to talk about tonight, but also how to create a simple linear data model to look at relationships in the data. If you remember last week, we did some correlations. Well, that shows relationships between data. Well, it's great to put it on a chart as well. So I'm going to do some of those things, but I'm not going to get into all the math because trust me, you don't want to go there, right? So we're going to stay away from the math speak about this. We're going to focus on the visual aspects and being able to interpret the charts from a visual point of view. We'll save the math for another class where all the math people can get in and have fun. All right, so exploratory data analysis, or what is also known as EDA, is an approach to analyzing data sets to summarize their main characteristics, often using visual methods. So charts and graphs and things of that nature. So before you actually apply models that are statistical in nature or machine learning, which by the way, you'll be learning machine learning in the data analytics bootcamp, you use EDA to understand the data, get a feel for it, uncover those relationships between variables, and to extract important variables. In other words, variables of interest. So you go into the data analysis process without a bias. You don't say, I think it's going to tell this story. You take the approach of, I don't know what it's going to tell me, but the exploratory data analysis starts digging through the data in a way where you let the data tell its story to you without you taking a preconceived notion to the data. So that's why it's about discovery and uncovering facts. All right. When you do that, by the way, you would be surprised. There's things that pop out that you would have never guessed. But if you go in with a preconceived notion, you tend to ignore those things, the goodies. All right. So the goal or the steps is to understand the data. So it starts with understanding the data set, looking at the variables, the structure of the data, some trends, and developing some hypotheses before you actually go into the analysis and or patterns. So you might be wondering, well, what is a hypothesis about? We're going to get a deep dive into that in the boot camp, but a hypothesis is no more than saying something along the lines, I think there will be a relationship between this column and this column. Or conversely, there will be no relationship between this column and this column. It's very simple. It's a guess. It's an educated guess. But at the outset, you take the hypothesis without the assumption of which direction it's going to go. So you always pose two. You pose the yes, it's linked. Yes, it's not linked, right? So you say it could be this, it could be that, but I just don't know. So, and again, in the boot camp, we'll talk about that further. Cleaning the data is basically getting rid of data that is going to have a negative impact on your analysis. So looking for missing data, deciding on how you're going to handle those null values, looking at the data types, making sure the data types are going to allow you to run the type of analysis that you want to run, looking for outliers and handling the outliers a specific way, and looking for duplicate data and or unnecessary data and getting rid of it. So it's making an educated decision about how you're going to massage the data, right? Or wrangle the data into a way that it's going to allow you to analyze it with the purpose that you have, right? So there's three flavors of data analysis that you want to know about. Univariate analysis is basically analyzing a single variable to understand the distribution, mean, median. And we've done some of that already. We focused on a single column in the data set and we said, well, I wonder what the mean is. I wonder what the distribution or the median is, right? So that's univariate analysis. Bivariate is looking at the relationship between two variables to get a better understanding of how they relate to each other, right? So think of bivariate as two things, right? Bivariate. Multivariate is where you're looking at more than two variables to understand interactions and relationships within the data set. You can make an inference that the more you add to the pot, the more complicated it gets. So multivariate can get very complicated because there's more columns that you're working with, whereas univariate is basically simple, and that's what we've been focusing on. Tonight, I'm going to show you a little bit of univariate and bivariate. And again, we're just scratching the surface. So that's why, I want you to be in the mindset of, I understand what these things are because I've heard about it. The next steps is visualization. So one of the most important tools that you will use in EDA is visualization. You can look at data relationships, but until you put it in a graph or a plot, it's very hard to make inferences about it, right? You can't use colors if it's just text. So common visualizations that are used are histograms, scatter plots, box plots, and so on. But you want to definitely visualize your data so that you can digest it differently. Now, what are we looking for? We want to try and find patterns and relationships. Well, in putting it in a visual form, you can see those relationships based on the direction. And if you use different color coding, you could then start seeing where outliers are because they're out in the galaxy, as it were, instead of clustered close to the other data points. So this is where you gain meaningful insights. Okay. So the other thing is modeling considerations. Now, we won't be doing any machine learning models in this course, but we will be doing it in the boot camp. So let me explain really quick what a machine learning model is used for. It's used for classifying data. So you want to classify data into two different classes. Now, our diabetes data set had a class column, a target column, right? Whether there was diabetes or not. It's either a 1 or a 0. It's either a yes or a no. You now have a class, and the class is the diagnosis, diabetes or not, diabetic or not. So that is so with a machine learning model, you train a model to predict based on a person's characteristics whether or not they will get diabetes. And you'll learn how to do those things in the boot camp. But for right now, you at least have heard about machine learning model. You kind of have an idea of what it is. But the big deal is you'll be able to measure the performance of the model. So I'll introduce you to different types and so on and so forth. So we won't go into a deeper dive than that because I don't want to scare you away. Now, data pre-processing. So in our class, thus far, we've gathered the data. I've provided the data set to you. So that's one aspect of data pre-processing. We have to have the data in our hands, right, before we can do anything. We then import the data set and the libraries. Well, you guys have already learned that. We've talked about how to deal with missing values. Now, tonight, I'm going to demonstrate a way of getting rid of those values. In other words, records with missing values. We're going to make an educated decision to destroy them. All right. And I'm going to talk about why you would do that. Okay. Because you don't want to destroy data just because. You always want to have a good data science case as to why you would get rid of data. And then I'm going to show you how to divide the data into a dependent and independent variable. And I'm going to talk about the difference between them. So you can see each week we get a little deeper into the forest, right? And things might get a little more confusing. But what we're not doing is what's in yellow. That we save for the data analytics bootcamp. So the data pre-processing we're not going to talk about tonight is how to handle categorical values. You don't know what those are per se, and you don't want to know at this point because time is short, right? We'll talk about splitting the data set into training and test sets. Again, I'll explain all that in the bootcamp and also scaling. But at least you understand that data pre-processing involves these 7 steps. Okay, so that's why I put them all there, but highlighted the yellow as to be determined, to be discovered in future times, right? Future classes. So in summary, EDA is basically an approach to analyze your data set, summarize their main characteristics from a visual perspective. The whole idea is to get used to your data, get a feel for it, become one with the data, look at possible relationships between variables, and to identify important variables. The goal is to allow the data to tell its story in a way that the person doing the analysis can understand. This allows for communication of results to others. So let's face it, think of it logically. If you were asked to take a data set and work with it, explore it, that's great. But what if you can't communicate what you found to someone else? That would be very bad. So the whole idea in these classes is to make sure that you fully understand what you did for homework, what the goal was, what your approach was, and what have you. This takes time to master. So if you still feel you haven't quite mastered it, that's okay. That's the purpose of us showcasing tonight, so you can kind of talk it through. And keep in mind that on the first iteration, you might not get it right. That's okay. That's okay. But the goal is to be able to communicate it and articulate what you understand to someone else. It could be a friend, a neighbor, a colleague, what have you. So that means you become the spotlight. You become the guru, and they listen to your words, and they ask you then questions. Well, what makes you think this, and why? What gives you the idea of that? And you can say, well, looking at the data, right? This is this. So again, we're going to talk about that. All right. So what I'm going to do now is stop sharing this screen, and I'm going to share the data dictionary really quick for the PIMA diabetes data set, because we did not do that. We talked a little bit about it last time, but we did not talk about the specific column. So I do want to do that. So let me open it up. I have it open on the screen, but I've got to find it. Bear with me, folks. So does anyone have a question they want to ask while I find this file?
I still don't have all names in the chat, please.
Oh, you don't? Okay. All right. Yes, please, please, please put your name in the chat. Very, very important.
Not for you. It's not for you. You're in person. You can give me a signature. They need to give me a digital signature. Okay.
That's right. That's right. Yes. So, and what's really important is that you do give that, because everyone is working so hard, right? You want to have your attendance logged, because that is proof that you were here, proof that you were engaged in the classes, right? And you wouldn't want to not get credit for that. So that's very, very important. Okay, I'm getting to my file. Somehow I closed it. What can I say? Things happen. Okay, let's share this.
I decided that I think I want to share one of my projects at the end.
Okay, wonderful. Thank you, Connor. That is wonderful. So when we get to that point, we will probably have time for maybe 4 people. So I think so far I have at least 2 volunteers, which is awesome. Awesome. Yay. All right. Can you guys see this? Our data dictionary. Woohoo. So the data set was small, right? It wasn't that big, but the columns have different values, right? So one of the columns was pregnancies, and basically the number that was in that column was the number of times pregnant. Glucose was the plasma glucose concentration. 2 hours, yeah, it's a medical thing, but it's basically a numeric value, right? Which I'm sure you recognize. The blood pressure was a diastolic blood pressure. The skin thickness was based on the tricep measurement of the thickness in millimeters. The insulin was a 2-hour serum insulin test, and the results of that, again, numeric. The BMI was also numeric. You can see a pattern here: numeric, 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 right? Diabetes pedigree function. This was basically a score that they got based on their pedigree and whether or not diabetes run in the family, right? And then, of course, age in years, and then the outcome. This variable right here is the target variable. Okay, the target or class variable. It's one and the same. So when you see an outcome and you see a 0 or a 1, that's an indicator that that's a class. And so 0 in this case would be not diabetic, 1 would be diabetic. And it's a great way of classifying. And I'm going to show you tonight in our data analysis how we use it in a meaningful way. Okay. Any questions on the data dictionary? Now, do you find this to be helpful? Because every data scientist has to have a data dictionary for their data set. Otherwise, you might take a guess. Well, this might mean this, or it might mean that, you know, you don't want to guess. So it's very important that you have that data dictionary. All right, I am going to stop sharing that screen and bring up another screen. All right, are we ready for the fun? So in the meantime, I'm hoping that everyone follows along. However, it is possible that depending on how many people can help in the classroom, we're going to have to step up the pace, only because we have the showcasing, and we want to make sure that we get time for the showcase. All right, so the goal is to not rush, but to at the same time leave enough time for that. All right, because we want to see awesomeness. Everyone's got awesomeness, right? I know you have awesomeness because I've heard about the awesomeness. So awesomeness is good. All right, so let me bring up a blank screen. Okay, and share it with you. I hope you're excited about this because once you get into this analysis, it really starts to make sense, I hope. That's my hope for you. That's my hope for you. All right, here we go. So you should recognize this. This is a blank screen, right? But I have a section in here. Let me make this a little wider for you. Can everyone see this okay?
Looks good.
Yes.
Yay, awesome. Okay, so I put a section at the top. It just says exploratory analysis of the Pima Indians data set. So what we are obviously going to do is import our libraries first, as we always do. So I'm going to grab these and put them in here. If you're following along, obviously you want to possibly copy and paste from a prior sheet if you have it. That will save you some time, because our goal today is to save time so that we can allow people to demonstrate their code and such. So we're using NumPy. Remember, NumPy is used for numeric data. We're using Pandas. Pandas allows us to get into, actually Pandas and NumPy work together, but allows us to analyze our data at the data frame level, which we've been working with. Matplotlib allows us to plot the data in charts. So does Seaborn. So Seaborn and Matplotlib are both visualization libraries that allow us to see our data, the trends in our data, and so on. There's a lot more libraries to do visualization, just so you know. These are the two classics, so that's why I'm working with the classics. Now, just like last week, and just like your homework, so you could copy and paste this from your homework, we need to create a two-dimensional data frame to import our data. All right. So again, I'm cheating a little. I'm copying and pasting it from last week because why not? To save some time. So I am going to actually run this and choose my diabetes file. You want to do the same. So you should have your data set at your disposal somewhere. And you want to grab it just like you've been doing. I'm going to go grab mine from Google Drive, and I have many folders, so let me grab it from the right folder. Again, I named mine diabetes. Yours should be named that as well. And you may have it in your class 4 folder if you tucked it in there. All right, you probably have it in there. All right, so it is uploading that data.
Is it too small this way? Too small?
Yes.
Okay.
You're going to make it a little bigger.
Okay.
Awesome. Okay, we're good.
Yes.
All right, so now we're going to actually do the import. And if you remember from last week, and you can copy and paste from last week to save you time, we're using import IO. IO lets us import or insert from a file and output to a file. So it allows us to handle data coming in and going out. We're going to read in our data using the IO library. And taking all of the data that it finds in a specific sheet, in this case, diabetes.csv. All right. So you want to make sure that that runs. Remember, you're looking for a green check mark. I have green check marks here, so I'm good to go. How's everybody doing? Okay. So far? Okay. If anyone gets stuck, remember, if you're in the classroom, reach out for help. Excuse me, if you're online and you need help, you can put something in the chat and we will try to help you. All right. Now, the next thing to think about, and I gave you the hint before, but when you read in your data, you want to display the first 5 records. Now, you might be wondering why. All right, so display the first 5. The reason, because if it may have imported or given you an indicated that it was successful, but what if the data is garbage, or what if the data got garbled coming in? You're not going to know that unless you read it. All right, so we are going to bring in the first 5 records, and the way you do that, just like last time, is df.head paren. All right, and let's see here. All right, so we have my uploaded is stating the upload is not defined. Okay, so what you want to do if you get that error, you want to make sure that you selected, first of all, that your code is correct, right? And then the second thing is you want to choose the file from your hard drive. Okay, so I'm assuming this is the one that was problematic for you, FundMe, it seems. So you didn't get to the
Yeah,
next step.
I already select the what's it called? The file is already selected. So I'm doing the import file to Google.
This one here. Okay.
Yes.
So
So I
make
already,
sure
yeah.
you've got single quotes around the name of the file and make sure that the name of the file that's specified is actually the name of your file.
Oh yes, that's the name of the file. Yes.
Yes. So make sure it matches. You might have named it something different, right? So yeah, always make sure that whatever it is on your system, you want to make sure that you named it the same and you're referring to it the same. Otherwise, it's going to say, I don't understand what you're trying to do.
No, okay.
So was that the issue?
The name is correct. Is where you write uploaded?
Yes.
So that's where I'm having the issue. It's telling me that this uploaded is not defined. So, but when I took the ED out, it works.
When you took the ED out, which?
Yes. You see where you said uploaded?
Okay. So you're saying you had to take the ED out and then it ran?
Yes, it ran.
That's very interesting. And you're in Google Colab?
Yes, yes.
Oh my goodness. Okay. So are you able to do the next step?
Yeah, I'm doing that now.
Okay.
Okay.
That's
Thank-
interesting. That is very interesting. See, you learn new things all the time.
Yeah.
Ay, right?
You got it.
Now, one thing to remember, it is case sensitive. So when you refer to bytes and IO and all of that, bytes IO is that case is very important that you follow that case. All right. Because it actually is referring to something in the IO library. And if you don't apply the proper case, it's not going to be able to interpret it. All right. So was everyone able to read their data and see the first 5 records? Yes, yes, yes.
Need some time.
Getting there? Okay. Okay. So while we're waiting, notice the outcome variable. Notice it's 1 and 0. So everyone should understand that that outcome column, it's named outcome, that is your target or class variable. So that's an indicator as to which records have a positive diagnosis for diabetes and which is negative. Now, keep in mind, and I want to say something that's super important. That outcome was derived by a clinical diagnosis. So there's additional anecdotal data out there, it could be doctor records or what have you, that cause someone to give someone a 1 or a 0. Okay. So we're taking it for granted that that was accurately done and it was done based on a doctor's diagnosis. So basically patient X, which we don't have any patient specific information for privacy, but patient X was diagnosed by a doctor and subsequently, got either a 1 or a 0. Okay. So, based on this data set, we take for granted that it's accurate is the point I'm trying to make. All right. Now, there are some issues with our data. I'm going to wait till everyone is able to see their first 5 records. I think in the classroom, we still have some people waiting to see the first 5. Once that happens, I want to talk about some suspicious things that are in these 5 records. So already I know that there's problems in the data and I'm going to explain why. All right, it sounds like we're good. So does everyone see that we have zeros in insulin, right? We've got 3 zeros here. We've also got a 0 for skin thickness. Now, how many people out there do you know have a skin thickness of 0? I don't know of any, right? So if our goal was to use skin thickness as a measure, maybe comparison or relationship between that and some other variable, we would not be able to compare the zeros with any reasonable assurance of success. All right. Well, wait, are we good in the classroom? It looks like we need some help there. Okay, let me know. Just give me a thumbs up when you're ready. So one of the things to think about when you read your first 5 records is, do we see anything that's unusual, right? And insulin of 0 is going to be unusual, especially since the goal is it's all about diabetes. And we know insulin is something that is related to diabetes, okay? And so when we start seeing records that have zeros in columns that they should not have zeros, we have to ask ourselves the question, do we want to include this record, or do we want to consider it suspect and not worthy of inclusion? Okay. Now, what we might want to do is explore further. So in the DF head command, we're going to ask to see 100 records. All right, to see if it's a prevalent problem, these zeros that we're seeing. Now, you're only going to see so many columns, but if you see any more zeros, I see one here, I can make an inference that if I have a 0 on the first couple records and I also have a 0 on the 96th record, that column is probably problematic. So that seems to be an indicator that we have an issue. Okay. I don't see any more for skin thickness. However, I am going to make a decision about whether or not to include these in a minute. Okay. I just want to wait till everyone's caught up. So if you want to take a minute and look at your records, you can. The other thing you can do, and this is something I did not show you prior, but you can actually, let me just move my little window out of the way here and make this bigger for you. You can actually click on the little pencil that I just clicked on to see your data set in a broad view. So you see how this looks like a little wand. It allows you to convert your data frame into a table, which makes it wider so you can see more of the data. You see that there? So now I can really take a gander at my data, and I see there's a lot of zeros for the insulin column. And notice on the right here, I can actually paginate through and scroll through, and I can also change the number of records I see at once. So if I change it to 100, I can now scroll through and see that we've got insulin values of 0, which does not make sense. We have blood pressure that's 0. If you have an individual with no blood pressure, no skin thickness, no insulin, look at this record right here. That's suspicious, right? That's probably a record that is not one we want to rely on because it's got so many zeros in it. See, here's another one. Look at index 15. We've got zeros in the blood pressure, skin thickness, and insulin. So we're exploring the data. We're looking at potential problematic areas, and we've already identified 2 records that are suspicious. If you look at index 22, it's 0 and 0 right here. You see, here's another one. So we start seeing some patterns of problems. You see that as I'm clicking down the line here?
Can you manage the width of the columns? Is it on you or it's on the collab not manageable?
Can I manage the width of the columns? You mean you're not able to see them all?
No, either too small or.
Okay, let me try something different. So I'm sharing my whole screen. So you can't see them, or how about now?
No, we're good. Generally, we're good.
Okay, we're good. Okay, I had just gone to a maximum screen, but I know what you mean. I have a wide screen, so that might be why. So does everyone understand the pattern that we've identified? Is anyone not sure? Everyone's good. Okay, so what I'm going to do, to get rid of this data table that I'm looking at here, I'm just going to click on the little X. If I mouse over on the left-hand side here, I can clear my output. I'm just going to get it out of the way so we can go on to the next exercise. Okay. So we already know that there are problematic areas in the data. We know that there's some zeros that are of concern. And as data scientists, we know there's an issue. So we're going to bring down another code cell, and we're going to describe the data. Now, this is something we did last time with a different data set, but we do want to look at the count of the data, and there's a reason why. If you have an inkling that you're going to need to delete records because of zeros and other anomalies, you want to know what you started with. How many records are we starting with? Okay. So we know that we have 768. Does everyone have 768 in their data set? Hopefully you do. So we know where we started. We know before we delete any records what we have. We then will make a case to delete records, and then we will describe our data loss. Okay.
See the number of records.
Pardon?
Where do you see the number of records?
Count on the first row.
Okay. Yep. Got it.
All right. So our count is the number of records in the data set. And then, of course, we get the mean, the standard deviation, the min, the max, and the Q1, which is our first quartile, our second quartile, and our third quartile. All right. So we know we have 768 records right now. We also know that there are zeros, and those zeros could be skewing our data. Okay, and we are more than likely going to get rid of them. But before we do that, we want to see how balanced our data set is. So we're going to bring another code cell down, and I'm going to scroll up, and we are going to determine how balanced the data set is. Now, that is done using our outcome variable. Remember, I mentioned we have a class variable that is diabetic or not. So to determine how many diabetics we have versus non-diabetics, we need to basically run a unique formula. It's called unique. It's a function. How many unique values do we have? And within that unique value, count them. So count the uniqueness of 0 and 1, and then give us the result. Okay. So I'll give you a minute to type that. Now, I'm also going to explain why this is important. So the first line prints out how many unique values we have, and it tells us we have only ones and zeros. That's this first line here, ones or zeros. And then it prints out the value counts within that unique subset. And you can see it tells us how many zeros and how many ones we have. So I'll wait till everyone gets caught up. This is really cool, but you're probably, excuse me, wondering, what does it mean? Well, it's all about distribution, remember? So it just so happens we have more diabetics than not, right? We have 500 non-diabetics, and we have 268 diabetics. So we have what's called an imbalanced data set. Okay. Now, you might be thinking to yourself, well, why would we want an equal amount of diabetics versus not? That's because we're looking for patterns in our data, and we need something to compare it to, right? So the fact that we have more non-diabetics than diabetics is a problem because, well, it doesn't allow us to fully understand the dynamics of diabetes. What we're trying to do is look at the numeric values associated with things like pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, pedigree function, age, yada, yada. We're not going to be able to really do that if we have an imbalanced data set. Okay. So that's something that this is part of our exploration. Now, one thing I want to share with you is just because we know it's imbalanced doesn't mean we destroy it with fire, okay? We don't go, we're going to kill the imbalance, we're going to get rid of it. You want to be super careful. You want to say to yourself, okay, What do I know so far? We have some zeros. We have some data records that have zeros in it, and that's a fact. So as you're doing these observations, you're taking notes, you know, on a notebook or what have you, and documenting your findings as you go. Mind you, we haven't done very much, but we've already learned very valuable information about our data set. Okay, so you're literally taking notes. This is what I found at this juncture. So does everyone have the imbalanced data set results? Everyone's good? And you should get the same results I have here. Okay. So now we want to know if we have any null values. Now we looked at 0. It's very important that we understand that 0 is not null. A 0 is a value, right? It may not be a realistic value. It may not be valid given what we know to be true. For example, all persons have blood pressure. If they show a blood pressure of 0, we question the extent to which they're alive, right? So a 0 is okay, but it defies what we know to be true. What we want to do is see if there's any null values, meaning no data in the cell, right? And the way we do that is we run a function called isNull. And we total them up. So the goal is to use the data frame, each column in the data frame, run isNull against that column, and then sum it up or total it. Okay. So we have good news to report. We have no not nulls, or we have no nulls. We have a lot of not nulls. Ay, 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 right? So that's a good sign. So there's hope for us. So we know we have zeros. We know we have an imbalanced data set, but we don't have any blank values. So as a trained data scientist, my guess is that they probably threw zeros in there because they didn't know what to put in there. Ay, ay, ay.
Question.
Yes.
How do you know you don't have blank?
I ran this function called df.isNull.sum, and there's all zeros here. So I added up every case of every record that was found to be null in each column, and they all came back 0, meaning there's no nulls. We're all good.
Okay.
Yep. Yep. So we're saying, is it null? Right? If it is, give it a 1. It gave all zeros, meaning there's nothing. So this is actually a good result. Now, let's say we got a result. Let's say for one of the columns, there was nulls found. We would then say there's a possibility we want to delete those, right?
Is it confusing or not? It would give once if it would be is not.
So think of is null. Is null is blank, no data, right? So we said, add them all up. How many are in each column? And it came back and said, there's none. There's no is nulls. We're good here. So is null means blank. Null, right? Is null is basically a confirmation that it's blank. So we have no blanks here. Isn't that good news? And when we run the dot sum, it's how many blanks do we have, right? Dot sum is going to tell us, count how many. And since we don't have any, it gave us 0 and says, this is good. We're clean here. So 0 blanks in each of these columns. Does that make sense to everyone? Now, remember in the Excel class, we're going to be going over null, lots of null, is null, lots of nulls, different ways of applying null. So it'll make more sense to you. This is why you need to practice with Excel, because Excel understands what null is as well. So in this case, we're using Python, right? We're introducing you to the concept. All right. So any questions on that before we move further? Everyone's like, I wish I had more coffee. Right? Don't hesitate to ask questions. It's all good. Any questions? All right. Now, we've made an educated decision. We have a post in the chat. Let's see what we have here. No questions. Okay, good, good. So we've made a decision. It's a sad decision, but it's an educated decision. We know how many records we have total, right? We have 768. We know that some records have zeros in them, and that's we're not going to be able to quantify the 0. We have to deal with them. So we've made a goal or a decision to delete any records that have zeros in specific fields. Now, since all of these fields are important, we're going to focus on the numeric fields of interest. So I'm going to paste this in so you can type it quickly. I don't want you to run this code until it's complete. So whatever you do, don't execute the code until you have all of the columns specified, okay? Because if you try to do it, it's going to throw errors. So we are going to remove, or rather, we are going to preserve any record in which the insulin is not equal to 0, the blood pressure is not equal to 0, the skin thickness is not equal to 0, the BMI is not equal to 0, and the glucose is not equal to 0. Okay, so we're only going to keep those records that pass the test that we've given it. If there's zeros, that record gets thrown out. So all of these columns, all 5 of them, they have to meet the requirement. If any one of them has zeros, the record goes. Okay. And I'll give you some time to type this. Again, make sure you have the 5 columns, very important. Now, keep in mind, we made this decision after considering several different aspects. This is going to create something called data loss. And we all know what we started with. And after we're done with this, we'll see what we are left with. And I want someone to give us a percentage of loss. I want some math savvy people, but we need to do it first. We need to accomplish the deed first. So when we're done, just give me a thumbs up. For those of you on the Zoom call, if you want to just give a thumbs up, if you go down to the bottom of the Zoom window, there is the gotta find it. You can actually give a thumbs up. And since I'm sharing, it's hard for me to see. So your reactions, yes, your reactions, you can give a thumbs up. This lets me know that you're done and you're okay. I don't want to move forward without you.
Does it matter if the skin thickness, if the T is capital and like what?
Yes, it does matter. So
does.
in Python, right, the field name is literal. So you see how how it's spelled here? You want to make sure you spell it identical because Python is case sensitive. That's a great question. Great question. And that's one of the reasons why when you're deciding what field names are going to be, you want to make sure you're consistent so you can remember them. Now, we didn't decide it, so we have to deal with what's given to us. But in the boot camp, I'll show you how to change the names of columns if they come in weird or wonky, right? So this is a pretty reasonable data set. In other words, they follow a reasonable convention for naming. What they do is based on change in word, they start with a title case. So it's easy to see, you know, blood pressure, skin thickness, and so on. You'd be surprised some data sets that you get. It takes time just to figure out what the data is, what it means, what they were intending. You become a detective of sorts. but that makes it fun, right? Being a detective,
Yeah.
that makes it fun. There's no boredom in data analytics. Trust me, no boredom. So again, you do not want to run this till you have all 5 lines done. Okay. So what we're basically doing, you might wonder, well, what is all these DFs, DF? What we're basically doing is we're assigning the results of the cleaning back to the original data frame. So we're literally replacing the original data frame with the cleaned up data, the data minus the zeros. So records that had these zeros in these columns are going to be eliminated, okay? There are schools of thought where you should create a new data frame, a new name, and do it that way. But for our purposes, we want to keep our data frame the way it is, but we're going to slim it down so that our data frame has just the data we want. Now, one thing to remember, some folks might say, well, if I do that, I'm losing my data. You have the original data file. Remember, when you import data into Python, you're importing basically a copy. You're not changing that data on your system, right? You're actually working with a copy. The original remains intact. Okay. In the data analytics bootcamp, I'll actually show you how to save out refreshed copies. So when you go to all this, hard work to clean your data, you can actually export out a clean CSV to share with your friends and family. Your hard work is, you're cleaning the data, and data cleaning, just so you know, as a job pays very well. Because there's a lot of folks out there that don't want to take the time to clean the data, look at the data. They consider it tedious, but this is so important, such an important job. All right. So now, if you're sure that you have your code typed correctly, you want to go ahead and run it. And if you have a green check mark, you can go to the next step. And the next step is to describe your data again. And notice the difference in count. Notice the difference. And you tell me what you got. We have 392 records left. We started with 768, didn't we? Remember way back? 768. Now we've got 392. Does everyone have 392? Hopefully.
Yes. Yes.
So we lost a lot of data, didn't we? How do you feel about that? Does it hurt your feelings? Does it hurt your stomach? Oh, I killed half my data.
No.
People struggle with that, I will tell you. So we made an educated decision. There was clear reasons as to why. So you never want to remove records on a whim. You always want to say, well, why would I remove this? Because it would compromise my data analysis, my ability to gain insights. So if you have zeros, that is, and you're looking to analyze quantified values, and you know that everyone has a BMI, everyone should have an insulin value, everyone has skin thickness, you have to question whether or not the record is even accurate and usable. And that's why you're making that decision. Okay. So it wasn't a rash decision. It was a carefully calculated decision, and that's okay. But when you do it, you always want to document it. So you would say to your client, you experienced this percentage of data loss. So roughly what percentage of data loss did we experience by reducing our records by the amount that we did?
50%.
Mm-hmm.
About 50.
Yeah, about 50, yes. So it's an approximation, which is fine. Now, that's a significant loss. So at the next step, you might say, well, why did we get that many garbage records, as it were? We'll call it garbage data. It's not a bad word. You might go back to the source, like let's say in the real world this happened to you. You might go back and say, we found a lot of records with zeros, problematic. Is it possible that your data collection, like the data set that you gave us, was bad, and could you provide another one, right? But for now, for our purposes, we're exploring. But in the data analytics boot camp, we will go through a deep dive into rationale and thought and decision making as a data scientist. For now, I want you just to understand that we experience 50% loss. And remember that, okay? And thank God your job's not on the line as a result of it, okay? All right, so now what we're gonna do is we are going to discover and group the data by the outcome, which is our target variable, okay, to see what the mean is. So what I want you to do, I'm going to scroll up here. We're going to group by the outcome. Remember, the target variable is very valuable because it tells us who has diabetes and who doesn't. All right. Notice that we're not including the outcome variable because it is the class variable. It's our target variable. But we want to group the data and come up with a mean for the zeros and the ones, the diabetics and the non. This is how you do that. So once you do that and you run it, if you want to volunteer an observation that you see, go ahead. We're training your eyes. And it's kind of interesting. Anybody?
They're similar?
Okay, so they're similar. So expand on that. How are they similar? In all columns or just a couple? Or
Apart from pregnancies, I think all of and insulin, all the other ones are pretty much around the same.
okay, when you say they're the same, what is the same? So you're saying that, for example, 68 for blood pressure is the same as 74?
Oh no, I guess like not far from each other.
Okay, so you're talking top to bottom here.
Right.
Okay, so the answer is yes for some columns and not so much for others, right? So let's look at an example here. So glucose for the non-diabetics is significantly less than a diabetic, right? So this is farther apart than, let's say, this guy right here, blood pressure, which would make sense if we're focusing on diabetes, right? Does that make sense? So here, again, this outcome of 0 means non-diabetic. So the blood pressure value for a non-diabetic and the blood pressure value for a diabetic, the span is not that great. It's not that big. 68 versus 74 is not a big difference as compared to the glucose, 145 versus 111, right? Right. Now, that makes sense because diabetes is about glucose or blood sugar values, right? So it would make sense that those with diabetes would have a higher glucose, right? So another thing to consider is insulin, right? So this insulin value is very high for the diabetic and less for the non-diabetic, right? But here's what's interesting. Look at BMI. Not big difference. And yet we're always told that weight has a lot to do with diabetes. It's not always the case, right? So here we have an interesting finding where there's not much difference between the BMI values for diabetics versus non-diabetics, right? We also have something that's interesting, and that's age. So the average age for the non-diabetic is 28, and for the diabetic is 35. Okay, so we often think of diabetes as being as you get older, you struggle with diabetes more, but it's not always the case. So you can kind of see where generalizations and stereotypes out in the world, people will say, well, you know, it's always those folks that get the diabetes, or if you get older, you're going to get diabetes, or whatever. It's not always the case. There's a lot of factors, and that's something we want to be cognizant of, that the data tells the story. We don't want to tell the data what it will be or what it should be. We want to look at the data and say, what is it? What is it trying to tell me, right? Now, there's also a big difference here between the diabetes pedigree function. We have 0.47 and 0.62. Now, we do not know, one thing I need to just say, we do not know if these differences are significant, statistically significant. We're going to learn that later on. Okay, let me just see some. Okay, so one of the things that I want to just you know, get you to think about is, if we see differences, we do not know if they're statistically significant. What we can say is it seems to be a difference between the glucose values for diabetics versus non, but we're not saying whether or not it's statistically significant. In other words, is it a meaningful difference, right? Big difference, pun intended. Oh my goodness. So the reason we did this is we want to see patterns and trends and see if we see anything unusual. Now, we are not, well, we're not medical doctors. I'm just going to make an assumption that none of us are medical doctors. I'm a doctor, but a different flavor, right? So we don't have an education in diabetes, but we, let's say, are being asked to analyze this data. We may have to do some research about diabetes and learn a little bit about it so that we can make observations based on the domain knowledge that we need. And we're going to talk about that in the data analytics bootcamp. How do we do that? So you have to become a quasi expert in these types of things to be able to determine, are these possibly meaningful differences? And when you explain your results, you need to be able to explain it with some depth, right? So this is just something to think about. Are there any other observations that you see here that you think are interesting?
Well, just by looking at the pregnancies,
Mhm.
how people without, like that are pregnant with no diabetic, the difference is like almost a 50% difference, no?
Yes, so those that have had children and the number of pregnancies. So the more pregnancies you have, the ones that are diabetic had more pregnancies than those that are non-diabetic.
It's
So
coincidence.
Yeah.
What's the cause? What's the
right. What does
result?
this mean, right? What does this mean? So that's a very good observation. But and here's the thing, it makes you wonder. Now, we all know pregnancy, there's hormones and all that fun stuff, but there's also, it could be regional, it could be based on the food that they're eating. You know, again, you have to think about culture, you have to think about, what do we know about this population of folks that we're analyzing? Because if you're going to make recommendations for possible treatments or preventative measures or what have you, you have to know things beyond the data, right? And sometimes you have to go out and research a particular geographic region, a particular culture. In this case, it involves Pima Indians, which it's a unique culture. It's in a unique geographical area. So there could be a whole host of things. But if anything, it's an observation, and it would warrant future research, future investigation, and maybe looking at other data sets and then comparing, right? So it gets fascinating, but that's a great observation. Great observation.
This one is a question.
Yeah.
So is it always a wiser thing to do the research so that you don't let those culture and myth and
prejudice and that you know about and hear about to interfere with the recommendations that you might provide to your client, for example, because looking at that, I can tell you my sister got diabetic, based when she was pregnant, and she has been dealing with that since. And
Right.
I don't know if now, I don't know. I thought it was something that happened to certain women.
Yes. So here's the thing. You raised a very good point. So what you would want to do when you're reporting out your findings is report them out exactly as you see them.
Okay.
And then if you are asked to expand on what are your thoughts about possible reasons, right? Statistically, you can see there's a difference, right? But you can't with any certainty attribute it to any one factor at this point. That's where machine learning and additional things are used. So remember, we're doing exploratory data analysis. We're only scratching the surface. You also want to be really, really careful that while you might be aware of, let's say, a relative or someone, you may know of a certain circumstance, but you want to keep that compartmentalized from your decision factor. So for example, you wouldn't want to say to your client, I think it's because of this, because my sister so-and-so, right? Because that's one person, right? It's not a lot of data. It's an unusual circumstance. And if anything, it could cloud your judgment, right? So you always want to keep it where you keep an open mind. And that's hard to do, right? Because if we've seen something, it makes us think it's always the case that it's this, or it's probably that, right? But it's an interesting observation. And as long as you articulate it by saying, well, this is something interesting that I observed, I wonder, and end the story, right? So always keep it in, I wonder, and subject to further exploration. Remember, if you're doing this for your client, they're paying you to use lots of data, analyze lots of data, and then render your findings based on what that data told you. If they ask you to do additional research and triangulate the results into an informed insight process, they're paying you for that, but you're using lots of data and you're adding that in. And that's something I'm going to be showing you in the data analytics bootcamp, because there's going to be cases where you need to get additional data sets to say, I wonder, and is this a thing, or is this a blip, or just an unusual circumstance? Right? So that's a great observation. Thank you so much for bringing that up. All right. So now what we're going to do is we are going to remember the correlation that we did last time. We're going to do one this time, but it's going to be interesting. We're going to do a matrix, a correlation matrix. I'm going to explain to you what this means. So every column, and I'm going to go ahead and just run this and give you time to type it. Every column has a location in the data frame. That's what iLock is. iLock is given the index of the column or the row and the location of the column, perform a function. In this case, it's the correlation function, right? So think of it as row by row, starting with the first column all the way to the end, run a correlation. Okay. Now we have several columns that we're dealing with here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that makes sense. Starting at the first column all the way to the 8. So all rows and the 8 columns are included in the correlation.
So pregnancies to pregnancies are 1, glucose to glucose are 1, right? So we
Perfect correlation, that's correct. So any value in any column will always perfectly correlate to itself, and that's a 1.0. So that's correct. And if you ever don't see that, you want to question whether or not it ran properly. So perfect correlation with itself.
Do you expect to catch the correlations by naked eye?
Say that again?
Do you expect to catch the other correlations with naked eye?
Yes, yes. And we're going to talk about which ones jump out at us. Yeah. So once everyone has this typed, first thing I want to explain is what these numbers mean up top here, this gobbledygook that we just typed, because that's special. You're probably wondering, why is the first space blank and then a colon? What's going on there, right? And I'm going to explain that. We all know about X and Y, right? So the X value is the entire axis, everything in the X. And the X is, what do we know? The horizontal, oy vey, the horizontal. So all, right, all columns, all rows rather, and 0 to 8 columns. So we're basically saying the entire data set or data frame except for the outcome variable, right? So we wouldn't include the outcome variable because of the nature of what it is. It's a class. It's 0 or 1. It's not going to work. So does anyone see anything interesting in our correlation? Ooh, I see something interesting. Now, the intersection between a column and a row is going to be the correlation. So right here, for example, is the correlation between skin thickness and glucose, right? Notice the intersection here. So that number is low, not very meaningful. Ah, but I see a meaningful one right here. Oh, 0.66. That's over 0.5, so it's worth chatting about. So there is a somewhat moderate correlation between skin thickness and BMI.
So
Yeah,
good one is
negative.
high enough.
Say that again?
Good correlation for you is high enough number, right?
Yes, yes. So anything over 0.5 is worth discussing. So there is a small correlation, a medium, and we're looking at the strength of the value, and then high. So 0.66 is just over moderate. It's not very strong. If it was 0.75, it would be even better. If it was past 0.7, the closer to 1, the stronger, right? So you start with 0.5 and you say, okay, let's see what's after 0.5. What's higher than that? Here's another one. It's going in the other direction, right? BMI and skin thickness, or BMI and skin, notice they're the same. They should be, right? Because it's the intersection between two variables. Now, in the data analytics bootcamp, we're going to be looking at this a lot. Here's something else that's interesting. 0.679 between age and pregnancies. Why do you think that would be a significant correlation or strong correlation?
Because they're opposite at the same time that you could compare them with the same percentage, no?
Well,
Oh.
what do we know about pregnancy and age?
Because people usually get pregnant at a similar age.
Well, not necessarily similar, but after a certain point, we're past childbearing years, right?
Oh, yeah.
So the older we get, the
more,
less pregnancies, right?
right.
Right.
The more
But
you get to get diabetic, the less you know. So basically,
right.
the younger you are, then the assumption is, okay, that person won't have
Right.
that. But if you are pregnant and you are a certain age, it's an assumption that you might not get it. But if you're older,
Right. Now, what this is showing us, one thing I do need to mention is this is not factoring in the class. So this data set that we've analyzed, we have not looked at whether they have diabetes or not. So very important. So when you're looking at these correlations, it's a mixture of both diabetics and non, right? But we know that as you get older, it's highly likely that there will be less pregnancies. In other words, if you've got a bunch of young folks, it's more likely that they're going to have more pregnancies, right?
right?
Okay, so there's always going to be a relationship between pregnancies and age. The more older you are, the less chances you have to have children, right? So that's what it's looking at. So there's always going to be a relationship between age and pregnancies, because at some point pregnancy is not possible. So it's going to be a strong relationship, just inherently out of the box, exclusive of diabetes, right? Because women only have babies up to a certain childbearing, and then they go into menopause and all of that, right? They just aren't capable. So because we're looking at a tribe of Indians, we have not only young ladies, but we have older ladies. So we have a wide generation of data. So we're going to have a strong relationship because of the nature of the population that we're looking at, the sample. So that's the other thing to think about. So you always want to think about what is typical and what would drive this correlation. What is it reasonable, or is there something unusual, right? So if, let's say, age was not correlated with pregnancy, we'd have to ask, are these super women? You know, they're having babies at 75 and, you know, God bless them, right? Yes, question.
Is this only women? Or is it men and women?
So it is that. Oh, I love that question. So
Um,
it is in this case, and
Only-
if I remember correctly, this is only women. Yes, this data set involves only women. I will have to double check on that, but my memory, if it serves me right, I'm getting old, I believe it's just a group of women. But that's where you want to research the Pima Indians data set and find out. But I think it is only women, if I remember correctly. But that is a great question. And though that's how you get thinking as a data scientist. What do we know about this data? We have a set of data in front of us. What story can it tell? Well, if it's only got women in it, it can't tell the men's story, right? So we know that we're working with a specific story behind the data. So therefore, our expectation follows from that understanding, right? From that understanding. So that's a great question. Okay, we have a question online. Go ahead. Yeah.
So my question is, I don't know if this is also pertaining. So I'm looking at the BMI, comparing it to the pregnancy.
Mhm.
Why is, like, what does it mean to be negative 0.025?
So
The
what this
BMI.
means is the number of pregnancies. Remember, the value that's in pregnancies is the number of pregnancies that the person has experienced, right?
Yeah.
The number of pregnancies is negatively correlated with BMI. So there's really, it's a negative and a very weak, extremely weak correlation. But that's a great observation. I'm glad you mentioned the negatives, because that has meaning as well. So isn't that interesting? Usually when, when you BMI is attributed to weight, you'd think, the more pregnancies, the lower the BMI, or maybe the higher the BMI because you gain weight. It doesn't seem that that's the case here, right? It seems, if anything, there's a slightly negative. And we would maybe want to investigate that further, right? There's another negative value over here. What do you think this means right here? So blood pressure and diabetes pedigree function. Now remember, the pedigree function is just, is there a genetic marker for diabetes based on our genetic predisposition?
That means that the findings were like no correlation whatsoever. Period.
Well, you say that because of the 0.01, right? So negative doesn't mean none, but it's this value here after the decimal that tells you. And a 0.01 is extremely weak to almost nothing. Remember, 0 is nothing, right? So that, right, this is superbly weak. So what's interesting is, given the genetics of this group of individuals, blood pressure does not seem to be a genetically prone problem where blood pressure, high, low, what have you. There doesn't seem to be a problem based on pedigree and diabetes. Again, we would want to, let's say we knew that there was, and we got this finding, we would question why. Why did we get this finding? But just at the outset, without knowing anything else about this group of individuals, it does not appear that blood pressure is an issue from a genetic standpoint. And assuming diabetes, and whether or not the diabetes has an issue on blood pressure, there doesn't seem to be anything there. So yes, that's a great point. So everything after the decimal, to the right of the decimal, is meaningful because that determines the strength. The minus sign is the direction. Anytime you see a minus, it's a negative relationship. Okay. Positive relationship is a positive number, and that means when one changes, the other goes up as well. So if it goes up and the other one goes up, that's a positive. If one goes up and the other goes down, that's a negative. Okay, so positive just means as one increases, the other increases. As one decreases, the other decreases. They worked in tandem together. That's a positive. Negative means they go in opposite direction. Right? So that's what you want to think about as far as the direction. So we've talked about strength of the relationship and the direction. Now here's something that's interesting. We'll make this the last one. So BMI and skin thickness, what do you think is going on there? BMI and skin thickness.
Opposite, that it's really like very small possibility that are known to the correlation between the right, the diabetes.
Well, what does the 0.66 mean? If a 1.0 is a perfect correlation and a 0.75 is a moderate to strong correlation, what does 0.66 mean?
Well, you could turn that into 6.7. Very close. Oh, I'm sorry, go ahead.
Go ahead. What do you think it means?
You go ahead.
Oh, for me, I might be wrong. I think it's a very higher correlation because it's very close to, it's very close to 1.
It's somewhat close to 1. I would say this is a moderate. If it was 0.75, it's getting closer. If it was 0.8, lovely, right? Very close to 1. This is going to be a moderate. So from a strength point of view, it's still above 0.50. So it's worth discussing, but it still isn't quite to the 7.5. It's not to the 0.75, but it is over the 0.50. So it's worth noting, right? It stands out relative to the other ones that are, very small, right? So this one is one worth discussing. And typically anything over 0.50 warrants further analysis, right? Because you want to dig down deep into the data and see if there's additional things that, stories that need to be told. So does that make sense to everyone?
The insulin and the glucose also has more than a half correlation.
Thank you. Yes, good eye. So again, that would warrant further investigation. Now, some people might say, well, it's not a real strong correlation, but it is, I would think it would be higher. In my mind, based on what I know as a layperson between insulin and glucose, I would expect it to be higher. So my first question would be is why isn't it higher? And is it possible that there's preventative treatments happening for these individuals? Maybe a change in diet, yada, yada, yada. It could be higher, right? So I would then, based on my observations, seek out maybe medical community to find out, is this an expected result based on their medical knowledge, or is it less? And if they say, well, this is less, we would expect it to be 0.75 or higher. You might then say, what additional data can I collect? Is it possible that they have a different diet and that's helping? Or maybe they're taking vitamins, or maybe they exercise a lot. There may be additional factors that explain this results, right? So since we're dealing with medical data, we would always go to the medical domain to ask additional questions. Is this a reasonable result, or is this something that is unusual or worth a future investigation? Additional investigation. So that's a great observation. You guys are doing fantastic. Oh my gosh. I wasn't sure if we would jump into this, but wow, you're doing wonderful. All right, let me show you how to do bivariate analysis. Yes, let's do this, right? So let's bring down another code cell, and we're going to do a scatter plot, and we're going to look at the relationship between glucose and insulin with respect to outcome. our class. So it's SNS.scatterplot. We're going to create a plot of dots, a scatter plot, a dot of plots, or a plot of dots. Oh, Lordy, it's too late to go there. Let's just say a scatter plot, shall we? We're going to use our data frame. On the x-axis is going to be insulin, and on the y-axis is going to be glucose. That's where we get the intersection, which is our correlation. But then we're going to color code our dots based on diabetic or not. So we're going to use blue dots and we're going to use orange dots so that we can visually see that relationship. So tables of data and correlations is great. Looking at it in a visual sense is going to be even more meaningful, but maybe not. I'm going to explain to you why this is maybe not telling the full story. But it still allows us to look at it and observe. Remember, this is exploratory data analysis. So we're observing and we're looking at it and saying, okay, now that we've got this result, what does it mean? What could it possibly mean? So I'll wait till everyone gets done there, and then we are going to discuss this. Now remember, it's called a scatter plot, and we can see scatter going on here, right? We see dots all over the place. But that's okay because it tells a story, and I'm going to explain what it means in a minute.
Or instead of,
Oh, jeez.
I think because you have
So it's nice that we have a legend of the outcome. We have the class as we know it. So the blue is the non-diabetic, and the one is, or the orange is the diabetic. And we can see some interesting things here.
So why didn't it come over the first time? Now,
No.
why are some of them quotes, double quotes? How do you know when to use the single versus the double?
It depends on what you're doing. Sometimes it will accept either or, and sometimes it wants the double. Typically, when you're working with charts, it's going to want the double quotes, but depending on the chart, it may want single. How frustrating is that? So,
Professor, I have a question.
yes.
So the SNS, do we have to define it before it can go?
We already did. So we declared that library up here. So we imported Seaborn as
Oh.
SNS. So we defined it up here. So once we defined it, then we can refer to it using the variable name that we gave it. So that's a great question. If we don't define it, remember, we're using the Seaborn library. If we don't define it, it's not going to know what we're referring to. So we have already declared that way up at the beginning.
Okay, I didn't say that. That's why I'm having problem.
Yep.
Sorry.
Yep. So that's why it's very important that you declare it and import it. Now, another good thing to think about is, let's say we decided to use another library and we forgot to declare it in the beginning because we didn't think we were going to use it. All you would do is add it to your declarations and rerun your import. And basically it would include the new library so that you can use it. And that happens
Okay.
sometimes. So
I
all you
think
have to,
that,
yep.
no, no, I'm listening. Sorry.
Okay, that's okay. So if you forgot to put it in the beginning, you can go back and add it and just rerun it. And again, we declared it as SNS. You could call it whatever you like, but SNS is the common variable naming convention for Seaborn. All right, so how's everybody doing in creating this chart? Good? All right, so some observations. We've got a lot of blue down here. So the less the insulin, right? The less the glucose. We've got clustering down here. And those people that are blue are the non-diabetic. So that makes sense, doesn't it? You know, not a high level of insulin, not a high level of glucose, and non-diabetic. We would expect the blues to be concentrated towards this quadrant down here, right? The orange is the diabetics, and we have some orange in there as well, which is weird because the insulin level is not expanded to the right for everyone. That's, in other words, we do have some concentration here, but the glucose is creeping up. You see how we get a lot of orange up in the upper left, or upper left-hand quadrant? So that means that the individuals, their glucose levels are higher, but their insulin levels are not, okay? What we do have is scattering, something called scattering, and we've got a lot of dots, almost like a little mini explosion in the upper right-hand corner. And we've got a lot of dots out there. So this is called scatter. So what that means is the data doesn't cluster around other data points like it. We've got some data points that decided they don't want to be friends with the other data points. So this is a problem because it's the diabetes outcomes are everywhere. We can't really make any inferences from this. We don't know what's driving it, and it's informative, but we need more. We need more. So I'm going to show you how to create what's called a pair plot. Now, when you execute this, it's going to take a while for it to render. So don't keep clicking to execute it over and over again. We're going to be creating a lot of comparisons here. So this is called a pair plot. We're going to take every column and compare it with every other column. So exponentially, we're going to, test the horsepower of our machines here. All right, so once you click it and it runs, just let it percolate like I've done here. It will eventually show the charts, but you don't want to click it more than once. As long as it's spinning, just let her go. Oh, cool beans. Isn't that awesome? So remember the correlation we did prior. Now we can see every data point or every column compared to every other column. And we can already see just at the outset that a lot of these are not related to each other. There's no relationship. There's nothing worth talking about. Some of them have lots of scatter, right? We can see outliers. We can see data points that are up in the sky and they're not close to other data points. But I will tell you, there is two relationships that are jumping out at me. The first I'm going to mention, and then we'll see, once I mention it, I'll give you kind of the pattern, and you then tell me what the other one is. So see BMI here on the left, and if I scroll over and I look at skin thickness, and which is towards the bottom, it should show you. You have to scroll down. Skin thickness and BMI has a relationship. Yeah, BMI and skin thickness. Now, that's this guy right here. Let me scroll down right here. Does everyone see this one? It's the fourth one from the left. You see how it's a linear relationship? It goes up in the air on a diagonal. The ones that are diagonal are relationships. So you see the fourth one in BMI, 1, 2, 3, 4, the fourth square from the left. That is the correlation between BMI and skin thickness. That one is useful in classifying the outcomes. Even though there's some outliers, we've got some nice clustering going on. Does everyone see that? Hopefully.
Why the others are not clustering?
Because they're not correlated. There's no relationship between them. Therefore, they're not clustering in a meaningful way. So remember, a negative relationship goes from the upper left down in a diagonal towards the bottom right. That's a negative. This one is a positive relationship. So when it starts at the lower left of the quadrant and goes in a diagonal towards the upper right, that is a positive. So the other ones are not in a sort of like an egg shape, if you will. They don't show a relationship in a linear way. And we were talking about a linear model. That's what we're looking for, a linear model. So the others are just not related. And or if they are related, there may be some skewing based on outliers. Okay, so because we've got a lot of dots that are all over the place in weird ways that don't follow that incline, that diagonal, that means that there may be other things that explain it. But right now, it looks as though that insulin, the relationship between insulin and glucose and BMI and skin thickness, both of those relationships are useful in classifying the outcomes, which is diabetes versus not. And again, this is our observations we're exploring. We don't have any statistical certainty. We don't have anything else other than this is our beginning of our observation. Pretty cool, right? Now, I gave you BMI and skin thickness. If we look at insulin, let me find insulin here. Insulin would be on the bottom. So there's insulin, and then I'm looking for glucose. And because my screen, let me make it a little smaller here. Glucose, so I have insulin, and I'm going to travel up to glucose, which is
All the way at the top.
right here. Right here. So insulin, let me just verify, is the fifth one in. And insulin is right here. Okay. So does everyone agree that insulin and glucose, there we go, insulin and glucose, I scrolled too far. This guy right here, see how it's somewhat of a diagonal, not a beautiful diagonal, but it's better than some of the others. Now it's somewhat steep. Would you agree? It kind of, instead of going like a triangle, it kind of goes straight up in the air. So it's an interesting diagonal. I would investigate it further because it appears there may be somewhat of a positive relationship. But it also appears that there are some outliers that we need to factor in. Does that make sense? Now, do you think the pair plot is more beneficial than maybe other types of charts? Is this beneficial to compare everything visually using this method?
I would probably choose a different type of graph.
Okay, tell me why.
It's open to too much interpretation of what's happening. Although we do have the two colors, there's a lot of scattering, you know? I mean,
Yes.
about the data, but for someone that doesn't really understand the kind of graph that I'm showing, if I choose to use this one, it might not hit the point that I'm trying to make. and.
Right.
You know, get home right away. visually.
Right. So
That's
one
right.
thing to remember, and that's a great point. One thing to remember is at this juncture, you're not making a point about the data. You're asking, what is the data going to tell me? Right. So in this example, we would still take the approach that it's telling me a story, but maybe the story is just not so clear. There might be a better chart, right? That would
Yeah.
help clarify things because of what we're seeing here. What is nice is we can look at the patterning and the clustering of the colors, right? And we could do it relative to other combinations of columns. But you're right, there's a lot going on here. And at this point in this exploration, we have additional insight, but we still need more, right? We still need more. So that's a very, very good point. All right. So obviously we could choose different charts that would help tell that story. And for time's sake, we won't be able to get into all those charts. One thing to remember though, is that in data analytics bootcamp, we will cover so many different types of charts and we'll be able to compare and contrast them. All right, which will be useful. But tonight, of course, we won't have the time. All right, so let's focus on, we're going to focus on, we did the correlation matrix last time. What we're going to focus on is distribution. And so we're going to do a very simple univariate analysis. So I'm going to scroll past here and add another code cell. And I'm going to just put the code in here. Let me make our screen reset it so you can see. All right. Can you see that okay?
Yes.
Let me, all right. So this is going to be a univariate analysis. And we're going to focus on all of our columns, but relative to the outcome. Now, this is a monster chunk of code for everyone to type. So we'll give you a chance to type it. And this is probably going to be one of the last ones we do just because of time. We do want to give people time to present their work that they did. But keep in mind that we will be doing a lot of additional charts and such when we do the boot camp. But we mentioned univariate analysis, so that's why this is super important.
Cynthia, it's all Python, right?
Yes,
And it doesn't matter, is it online Python or installed Python? You just need all these libraries.
that's correct. That's correct. So what determines it is the version of Python that's running on the machine that's running it. So right now we're relying on Google's version of Python. If you do it locally, which I will be showing you in the boot camp how to do it to the extent that we're able to, you always want to know, does this version of Python support the library? And you might need to get the version of the library that's working for that version of Python. Yeah.
Saying that there are tons of different libraries and tons of different
Yes.
functions, as per se, you just need to learn specific functions
Yep.
applicable to the data analytics scenarios and such.
Yes, yes. And that's why I've picked the classic libraries. So that we're working with the libraries that if you're working in Python, you will always work with these libraries. So we're focused on NumPy, Pandas, Matplotlib for the PyPlots, and Seaborn. That's the classic four.
You need to memorize all these functions and commands because there are just like core commands, right?
Yes, exactly right. So if you want to create a histogram, you have the code to create the histogram and you just plug in the different name of the variable, right? So a lot of it is finding out what the code is for a specific chart, but also applying it to the situation. So if your columns were named differently, you might have to swap out the column name and such, right? But that's a very good point. That's why you always have a lot of notebooks that you can reference for future, because you'll never memorize this 100%. It's just not possible.
So you're creating your own vocabulary, or I would say dictionary.
That's right. That's right.
Most useful functions and most useful libraries right now.
That's right. That's right. And you want to bookmark all of the documentation. So for example, there's documentation online for Seaborn. and matplotlib and NumPy. You want to have that at your disposal. So if you get stuck with NumPy and you can't figure it out, you go to the documentation and you say, oh, it's supposed to be this. It tells me it's supposed to be this. So I will, you know what I mean? So it's having that library of tools and information available to you so that when you get stuck or you can't remember, or maybe you want to do something slightly different than the one that you did last time, you might need to research a little, and that's okay. No one's expected to remember all of this, and that's why there are communities online, like in Stack Overflow, and a lot of communities that will help you as well, because there's sometimes you get stumped on a problem and you can't figure it out, and that's why there's a whole community of people that are willing to assist.
But the most important, you have your own small library of
That's
multi-function.
correct. Yep, you got it. That's right. And it could be in a sheet, you know, maybe it's a spreadsheet where you make a list. It could be a Word document that you can search, you know, whatever you need, but you want to document these libraries I use for this, you know, this I use for that, and so on. And that's where taking notes is very important. And you learn a lot of that, more of that, I should say, in the boot camp, because we're going to be working with so much, and you'll see patterns. We work with this again. Why this library again? Well, we're using it for a very specific reason, right? Or I might introduce a new library and I might say, well, this is why. So someone mentioned earlier, well, this chart doesn't necessarily, I might need more because it's too busy or it's too this. Well, let's try a different library and a different style of chart. Right? Or in other words, everything has a clear rationale for it, a choice, and it's based on what is the goal. Everything's goal driven. And so that's something that's very important. You'll see common goals, and then you'll see cases where you need to switch gears because maybe the data revealed something you weren't expecting. And you're looking at it saying, wow, now that I have this, I need to bring in this library because it'll help me understand further. So like I said, you become like an inspector with a magnifying glass, analyzing the data. And there's never any boredom. You're never going to say, oh, it's the same old in data science. Oh, no. There's going to be a lot of interesting things that come up and you're going to say, wow, I would have never expected that. Or something like, wow, I just imported 5 million records. I didn't think I could do that. Now that I have them, what do I do with them? Right? How's everybody doing? Getting there? So here we're using a for loop. Remember we did for loops, right? So for every I, which is every index and column in the set of columns, considering the outcome, which is, we know, diabetics, yes or no, give me a subplot. So you'll start seeing these patterns, right? So if we need to iterate or repeat the process over and over again, enumeration of a set is, give me a set of columns, right? This is where, you know, we started with those classic structures because of this. So I'm going to execute it, at least show you what it looks like. Ah.
Nice. Much, yeah.
Ah, right? Much better. Now we can see some normal distributions, thank God, right? Yeah. So now what we're doing, again, this is univariate analysis. We're looking at glucose by itself, right? Blood pressure by itself, okay? Age, okay? Diabetes pedigree function, and so on and so forth. But with respect to outcome, all right? So we're classifying the outcomes based on column by column. Column by column. This is univariate analysis, where we isolate or explore each variable by itself. And what we're basically doing is counting. Now, does anyone see any normal distributions? If you do, identify it. Now, not perfect, normal, which normal is relative. Ask anybody. Is there anything that seems normally distributed?
Well,
Blood pressure?
Blood pressure, excellent, because it follows that bell curve, right? What else? Okay, somewhat, yep. And BMI, somewhat, right? We still have the little tails going on here though. So they're skewing, right? They're skewing. So forget kurtosis, that's another animal, but we do know that we have skewing because we have tails here. Okay. Now, is it positively skewed or negatively skewed? Is the tail on the right longer or shorter? Longer. Therefore, it is positively skewed. That's right. That's right. Excellent. Excellent. See? So now you can see these trends, right?
So blood pressure will be like positively and negatively skewed, right?
Actually, you can't be both. This is actually very little skew, if at all, because there's tails on both sides.
Right.
So this has symmetry. There's tails on both sides. Therefore, it is basically a normal distribution with little to no skew.
Okay.
Yep. That's a great question though. So you're looking for, if you see tails on both sides and a bell in the center, that's normal. And that has symmetry on both sides. Whereas over here, we have no tails over here, but we have tails on the right. You see, we have little data points on the right.
Or like the ones that do not correlate at all, you see like it starts real high and it's just like.
That's right. So it's very skewed
right,
and not normal, not symmetric, not symmetric, right? So for example, remember we looked at outcome and we would expect insulin to not have a normal distribution related to diet. Right. Same thing with pregnancies. And that matches what we observed earlier. Remember, we said that seems that, so that matches what we saw earlier. So we're starting to see patterns of, over and over. What I will share with you though, is there is outliers in this data. And so that is skewing our skew. God help us, right? That's skewing our skew. So we know there's outliers in the data. And so that's something that we would need to address in further analysis. Okay, so here's what I want you to do. I'm going to give you another chunk of code, but I want you to copy and paste this code and tweak the code to make the new code work. So you're going to copy and paste this code to the next cell, and then you're going to make it look like mine. I'm going to copy mine in there. And what I want you to do is just tweak. This is where you're copying a known chart that works for you, but we're going to change the chart style to a box plot. So there's some things you need to massage. You're going to massage it so it looks like mine, and then we're going to run it. And that will be the last thing we run. And the reason we're running is we want to see what's got outliers and where. We know there's outliers. We want to see where they're at. So this is a box plot that we're creating. All right. And again, the code is very similar to what we did prior. Some of the numbers change because of the size, the subplots that we're doing. There may be a few things you need to add, but why type it all over again when you just tweak what you have there, right? That's called being efficient. Not cheating, but being efficient. Another for loop, right? Who knew? A for loop on a set. Isn't it great that we learned that?
How'd you get that?
So to undo something like do control C and
Oh,
see that
C.
what's that. This is the part.
Thank you. That's the most we're getting. Okay.
So this is a box plot for grouped data.
Oh, because I had a chain.
It was. There you go.
So everyone's got it. Isn't that cool? So copying and pasting code is awesome, right? So what does this tell us? Well, this tells us that we have outliers. How do we know that? Well, we know that we have whiskers. Remember in your box plot, those lines that go across top and bottom are your whiskers. Anything outside the whiskers are outliers. So you see these diamonds outside the whiskers? Those are outliers. We got a lot of outliers here. So age, we've got a lot of outliers. Glucose, we have some. Diabetes pedigree function, we have a lot. Let's see, BMI, we have a lot, right? Pregnancies, we have a lot. Okay, so we have a question here. How to send one of these sets. Now, can you explain a little bit further? Are you able to speak in the microphone? When you say how to send one of these sets, where are you sending it to?
To our employer. If they asking.
Okay. So you're trying to set the send the data set to the employer?
Yes, if they
Oh.
asking.
You could email it to them. You could upload it to Dropbox.
Okay, so they don't have to have a Python or anything to read it. It can be just inserted the picture, or is that?
Okay. So that's something different. So if you want to send the visualizations and such, that's something that you would render a report and send it to an employer. So that's why when we do our data analysis in the boot camp, we're going to be putting it up to GitHub, and we're actually going to save all these findings as a report, as a PDF. I think that's what you mean, right? So to have the report of findings, is that what you mean? Yes. So that's a great point. So what we're doing right now is assuming we're not reporting it out. But in the bootcamp, I actually show you how to create a PDF automatically from all of your data analysis. And what's really nice is you can put in captions and things like that to explain your findings. So it's a professional report of your findings. So that's a great question. And I'm glad you asked that, because these charts tell a lot of story, right? That we can visually see all of these outliers. Now, notice the outliers are, there's little 0 and 1 on the x-axis. So that's diabetes versus not, right? Or no diabetes is the blue, right? And the orange is the diabetes. So there's outliers for some and not others, right? So when it comes to glucose, there's no outliers for non-diabetic, or I'm sorry, for diabetics, but sure enough, there's outliers for the glucose for non-diabetics. And remember, we saw that earlier? Well, there it is in the visual. So these outliers are skewing these charts above here. They're having an impact on whether or not they're symmetrical, normal, and the skewness of the data. All right. So let me explain it in simple terms. Any outliers will have an impact on all data points in the data set, and the outliers defy the norm. So sometimes we will make a decision to not include them. Moving forward, we might say any records that have outliers, we get rid of them. And that's where we engage in a process called transformation of the data, which is outside of the scope of tonight. But in the future, I will teach you how to handle the outliers. and different ways of handling them. You might delete them. You might replace all the outliers with the mean value, the average value for all data. There's different ways of handling it, and we'll talk about the rationale. But for tonight, our purpose is just to identify them. Okay. And you can see clearly we've got a lot of diamonds outside the whiskers. Diamonds outside the whiskers. All right. So does everyone see that?
Can you keep showing code a little bit longer?
Absolutely. Absolutely. Let me go up. Can you see okay?
Yeah.
Awesome. Do you see how the code is very similar to the prior code? You had to change the type of chart, right? So we went with a box plot. The one that we did prior wasn't a box plot. It was a little bit different. All right. It was a histogram or hist plot. But this is where you can just make some simple substitutions. So does everyone know that in Excel, when you create a chart, there's an x-axis and a y-axis? Notice we're referring to an x-axis and a y-axis. For our data, we're referring to a data frame. Well, in Excel, you refer to a range of values in the cells, right? Columns and rows. Or you might have a table of data that you refer to for your chart. Same thing here. In Excel, you choose a type of chart that you want to see, a pie chart or a bar chart. Here we're doing a box plot. So you can see the process or the thought process is very similar. The syntax is different. We're generating it using code, but all the principles of charts as we know it are the same. We have labels on both axes. We have, in some cases, tick marks. So here we have tick marks on both axes, right? On the x-axis, we only want to see the outcome, either diabetes or not. Why? Because we're having two different colors of box plot. So they're side by side for comparison. Pretty cool, right? We also determine our figure size. How big do we want our overall chart? So the whole chart has we'll call it real estate. It takes up a bunch of room. So our figure size is a nice 20 by 20, it gives us enough room for all the subplots to generate and be visible. Pretty neat. Anyone else have trouble with the chart at all? Everyone able to create it? Good. All right. So I'm going to wrap up my demo here because we have two students that want to present and I know the library closes. So I'm going to stop sharing my screen. And I know that Connor wants to present. And let's see, someone else wanted to present and I'm old and I can't remember. Oh my goodness gracious. Who wants to present first? All right, Connor, unmute yourself and show us what you have.
I can present.
That's okay. That's all right.
Let's see.
So we'll do about 5 minutes each person because then we have to wrap up to to get ready because the library closes.
So this is the one where I made a game.
Mm-hmm.
It's a sort of choose your own adventure thing.
All right.
And let me run. So I printed the beginning
prompts, right? Okay.
I don't know why it's taking so long. Maybe if I refresh it.
Yeah.
Okay. There we go.
There you go.
All right, so with the first thing, with an example of global variable selection control, you had 3 choices. I'll choose knife. And it displays, depending on which one you chose,
Mhm.
with if, if, else, when accurate there. And it stores it in weapon choice for
Okay.
later use. Here's an example of using a list. And I made a list of names you can pick from.
Mhm.
I put just a variable. Technically, this could have just been a string.empty, but or empty string, but I just made it a. Made a function to make a list of the names, and for name in available names, num plus
yep.
equals 1. So it could see each one
As a
pick
list,
the
very
number.
nice. Yep.
List names. So I did that. Then choice number equals int input, and I made sure it was an int
Mhm.
with that. Unit name equals available names, and then I had to put the -1 because
One past the list. Yep. Right?
because it starts at 0, so
Mhm.
yeah, the number would technically, like, if you put in 1, it would actually be like the 0 on the
Value. You got
the
it.
list.
You got it. Excellent.
So I'll
Excellent
put
point.
in 1 here. All right, your new you get drafted into service in defense of a city. All right, your new unit is now called the Eagle Watch.
Excellent.
Now this one I had a bit of trouble with, because I was trying to figure out the best way to display an example of a dictionary. Eventually I just decided on choosing each one, and instead of using an int to do the selection, I would just do typing in the name directly.
Okay.
And
Cool.
and in the last one, I tie it all together with all with the global variables with your trusty knife and your new comrades in the
The Eagle
Eagle
Watch.
Watch. You begin your journey in defending the city. And yeah, that's
Nice. So it's like a text adventure game, which I'm addicted to. Fantastic. Fantastic. That's a very good example. You've got all the key components that we went over that week. So bravo. Very cool. You got a lot of thumbs ups on that.
Thank you.
Excellent. Connor, thank you so much for sharing that. Excellent. So very creative. And that's really what we were looking for, is you to get creative. So thank you for sharing that. Anyone else want to share? I think we had one other person that wanted to share. We have maybe 2 minutes. We're kind of getting low on time. If not, that's okay if we don't have time. So any questions before we wrap up? Any questions? Anything we want to ask regarding the boot camp or the classes? Yes, congratulations.
Registration.
Yes.
Do we just reach out to Yulia if we
Yeah.
want to register? Okay,
Yeah,
thank you.
yeah, absolutely. Yes, yes, yes. Congratulations, everyone. You survived. So the boot camp will be the same hours and days. Yes. So we're keeping on Thursdays from 5 to 7:30 like we've been doing. Yes. And keep in mind that the boot camp starts next week and it goes all the way through January.
Wow.
Yeah. All right.
Good question.
Yeah, Yulia, do you have anything to say?
Let's hear a question.
I have a question.
Okay.
Yeah, I just wanted to ask, because I join the class, you know, the introduction a little late, but I'm willing to complete the lessons in the class. So could I submit those, I think it was in the class number 3, which I like the Excel, the Python, and all of those things that
Yeah.
the
You want,
pressure, although I did all those separately, I would like to submit them. Should I submit them to you directly so that by next week you could give it a thumbs up? That I'm
what I would say is put it on Slack and also meet with one of the TAs so they can review it as well. But yeah, you just want to show that you have accomplished those things so that you'll be prepared to jump right in. So feel free to post those on Slack and ask a TA in office hours to review them as well, because we want to make sure that you're ready. Okay, so awesome. That's a great question, and kudos that you're trying very hard to get caught up.
Yes.
And I want to take a chance right now and to give free pilots away. I would say Nancy for the most hard work she was attending.
Yay!
And she likes web development more so far because it's easier. Data analytics was so challenging, but she was committed.
Yes, excellent job. Yay, everyone online is saying woohoo.
And Debbie, Deborah, good job. Yeah.
Yay, awesome,
And
awesome.
delivering your homework, at least 50% of homework has to be done. And even if it's a mistake, just bring it here, share, give
Yes.
feedback from our TAs, right? And Steven, I have one for you. I'm giving it a little bit in advance, because we, formally speaking, we still have office hours, you still can deliver more.
Yes.
So we don't have a hard stop for this. Whenever you're ready, it will be checked against your parameters, and then you will receive your certificates.
Will the boot camp be recorded?
Yes.
The same thing.
Same format. Yep. Same format. Yes. So, and the beauty of that is you can go back to the recordings. We encourage that because you will forget things and you want to go back. So all the recordings will be posted on Open Hub. Yep.
And how could I join, like, let's say that one day I can't be here physically, how could I join like some of the people that are there online virtually? Is that something that Julie could do for
And
me?
I will share my screen right now because I'm always here. Oh wait, excuse me. I will share my screen.
Yeah. Don't forget the Zoom link is always posted on Open Hub.
Yes, that's what I'm showing.
Okay.
Oops. Let me move
Yes,
things
sir.
up. So here is your class,
So like that,
right?
okay,
Here,
but
when
what
you
is
see your
part of
data
it?
analytics class, for example, or when you see your classes,
Uh-huh.
you see all this Zoom link.
So that's like for, but it says resources, this is for me to be in the class during class?
On Zoom.
Yeah.
Yes, you can join on Zoom.
Yeah, because
And
I started a third shift job. And it's being hard for me, like I'm losing sleep right now because I want you to know how committed I am to this, Julia. You know, and regardless, like that job is coming to an end. I want to nail this. I know it's gonna put me at a different level.
absolutely, yes.
Professionally, so I'll do whatever it takes to.
So once again, as a reminder, Zoom recording is here in each class when we have it. So you will see the Zoom recording for this class in a few days, and tomorrow in the class 5, right? And your certificates is, once again, I'm the holder, I'm a gatekeeper. And the red line against everything.
You gotta write a program to get your certificate.
And those who want to have the handwriting autograph, you will get it if you want. But last announcement, once again, I'm still sharing my screen, right?
Yes.
So once again, just a reminder, we've been doing these Thursdays, 5 to 8, actually. And we will continue with the bootcamp here. We're switching gears. We just kind of done with Python, but please refresh and watch and finish the Python. Now we're starting with Excel, and then we will go back to Python with new knowledge of, new understanding of Excel. Back and forth, you will see new patterns and you will nail your CAD, you will nail your expertise, and you will nail your patterns, pattern recognition, I would say. We're doing everything just to have you succeed with all these things. So we are providing complementary classes. That's why we are starting with the Excel here, which is expected to be intermediate plus Excel. And that's why we're supporting with Excel basic to intermediate. So we're giving you heads up, or we're giving you like push up. I don't know how to say deep dive.
Deep dive, yes.
Into this. So it will go in parallel, just to refresh your basic and
That you
intermediate
could
knowledge.
take at the same time.
In
say.
parallel, yes, on
Ah.
Mondays in person 10 to 1. Excel. And then we are doing the boot camp with the specific data analytics, data scientific use cases, scenarios, because we are combining different multi-dimensional approach here, not Excel itself, but we are putting this into work with data scientists, cleaning data and preparing your data, analyzing your data with different graphs on Excel versus graphs on Python. You see how useful Python was, just cleaning this data, just doing the hard work, like delivering you everything is clean, or just look at this. And then now as a scientist, I can make a decision and dive deep into that. I'm just crazy passionate about this. One more thing to mention, we will have, SWOT analysis for career development, SWOT analysis for your personal strengths. And this class will be on Zoom next Wednesday, tentatively, but like 88% next Wednesday. So, is it doable for you? No? Evenings?
No,
No?
but is it next Wednesday, or is it Wednesday?
Right now, I have a placeholder for both, but a SWOT analysis for career development on 23rd is the 90% probability.
So if it's not the 16th.
It's not the 16th.
Then I'm good, I can do the 23rd.
23rd. So it's not next week, we need a couple of weeks, right, before that. And we actually want to apply our understanding of data analysis and gap analysis and SWOT analysis into our personalities. Cool, right?
Yes, it's fair enough.
Okay. So you will be not performing gap analysis on your personality.
But that would be too crazy, too many probabilities.
Oh, no, you will learn something about it.
We will never be done.
All the links, all done on.
Yeah,
published on Slack. I'm just saying the Zoom links, all of that will be on Slack. Keep eyes on Slack. Okay.
Is that calendar on Open Hub? That calendar that you just showed?
Okay, let me grab the link for you for this calendar. It's living, breathing calendar, which everyone still have already by now.
Okay.
On Zoom. Oops. It's a short link. Easy to remember. It's living and breathing document. And I will remind about this on Slack as well.
So we get a certificate for the website. I'm not interested.
Thank you.
All right. Take care, everybody.
Thank you.
Thank